So hello everyone, in this tutorial I will explain about all types of series diode. So before beginning the tutorial I will clarify about something. This is a diode and this is the positive terminal of the diode and this is the negative terminal of diode, and there are two types of diode. One is ideal diode and another is practical diode. So practical diode has their own voltage. Suppose these are the practical diodes. This is germanium, this is silicon, and this is gallium arsenide. And germanium voltage has 0.3, silicon voltage has 0.7, and gallium arsenide has 1.2 volt. So I will explain about all types of diode. After ending the tutorial, I hope you will be able to solve any kind of series diode problem. So I will start with type 1. So in the type 1, what's inside there? 5 volt, silicon 2.2. Just look at the voltage terminal and diode terminal. There 5 volt voltage go through the silicon diode, and where I can see silicon diode is forward bias. Why? Positive 5 volt goes through the positive terminal of the diode, so the voltage can easily pass through the diode. So I will draw the alternative circuit of this diagram. So if the voltage can pass through the diode, the circuit will be like this. And what is the diode? This is silicon diode, which voltage is 0.7. and now we will apply KVL on this. Plus 5 plus 0.7 plus, what is the resistor value? 2.2 I equal to 0. So after solving the equation, we will get I value is 1.95 milliampere. So this is type 1 diode. So after the type 1, we will go to type 2. So in the type 2, what can you see? This is positive terminal, but the diode is opposite. So positive voltage gone through the negative terminal of the diode, so there will be a reverse bias. In the type 1 there will happen forward bias, in the type 2 there will happen revert bias. After the revert bias, the diode will be open. So I draw the circuit. So I draw the alternative circuit. So the circuit will open. So if we do KVL in this loop, so we can find their current will be 0 for the reverse bias. And now we will move to type 3. So what you can see, there is 1 volt voltage go through the gallium arsenide diode, and the diode type is forward bias. So in this diode, gallium arsenide value is 1.2, as we told you before. The gallium arsenide voltage value is 1.2, but they are passing only 1 volt current, which is less than gallium arsenide voltage. So this 1 volt voltage is less than the gallium arsenide terminal voltage. So gallium arsenide diode will be off, so the circuit will open at the diode. So this is same at type 2, their current will be 0. Now we will move forward to type 4. So what you can see, the negative 5 volt voltage try to go through the germanium diode, and germanium value is 0.3, but as you can see they are negative and there is positive, so this is a reverse bias and the circuit will be like this. So the current will be also 0 in there. Now we will move to the type 4. So here you can see the minus 5 volt negative voltage goes through the germanium diode, which is also reverse diode, but they are negative, that's why this is a forward bias. So the diode will be like this. There will be 0.7 which is negative, as you can see, 2.2. so I want to do a loop in there. Minus 5 minus 0.7 2.2 I. So after solving the equation we will get I value equal to 2.59. So now I will discuss about type 6. So here you can see the voltage is 1.2 volt, but gallium arsenide voltage is also 1.2 volt. So at the same time there will be happen two things. One is forward bias and another is reverse bias. So if you solve the equation you will find both of the current is 0. Now I will discuss about type 7. There is 5 volt voltage. There is silicon diode which voltage is 0.7 and germanium is 0.3. So nothing is difficult. After applying KVL, the equation will be like this: plus 5 plus 0.7 plus 0.3 plus 2.2i equal to 0. So after solving the I, we will get I value is 2.72 minus 2.72 milliampere. Now at the type 8, what we can see, there is 2 diode, 2 resistance. So the equation will be like this. So I hope you will understand the alternative circuit. So I am doing the KVL directly without drawing the alternative circuit. Plus 10 for the silicon, 0.7, 2i, 1.2, 3i equal to 0. So I value is 2.38. milliampere. So this is our last diode. I just make the alternative circuit. $10 volt. The silicon is forward bias, that's why the diode is open, so that's why the diode is on. And the resistance same here. And the gallium arsenide, you can see this is the reverse bias, that's why the circuit will open. So for the reverse bias, I equal to 0. So 0 milliampere current goes through the whole circuit. So that's the all types of diode I have discussed. So if you faced any problem, just feel free to ask me in the comment section. So in the next tutorial I will explain about parallel diode. So hopefully you understand the video. So see you soon in the next tutorial. Thank you so much guys.